Now that we've seen some ways to connect up components in a so-called series circuit, let's consider what's known as a parallel circuit. So let's suppose that I want to send current through more than one branch. For instance, let's say I want to send current through this resistance box, and another branch will send current through this resistance box. Let me show you a way in which you can connect the devices up to one another to accomplish that very thing. Well, we have our connectors, being mindful of choosing appropriate lengths. Now what we can do is we can connect those two into one another. And by so doing, we now have a top branch that will go into the top resistor and a lower branch going into the lower resistor. So you can see this is what's known as a junction or a node. So from this point, we're branching into two separate parts of your circuit. Now, at some point, you're going to want your circuit to come back together. And so let's say we want to do that on this end. So once again, we can connect on, let's call it the output on the first resistor box and the one that's on the bottom, and we can bring those back together once again. And so now what we've done is we have two separate branches, if you think about it. One going along the top, one going along the bottom, but we need to complete the circuit still. So let's say that we wanted to do that using our meter, and suppose what we want to do is we want to determine what the overall resistance is of each of these. So once again, I have a setting of, let's say, 50 ohms for this one, and I have a setting of 30 ohms for this one. And what I can now do, if I want to make the, let's see if I can set them like this so you can see. I want to now connect these guys up into, let's do it this way, the meter itself, and I can go into COM, and I can go into this right port, because what we're trying to accomplish now is measure resistance, and in this way we can get the resistance of the two resistance boxes as they are in parallel. So now we've completed the circuit with the meter itself, and if you recall before, when we had these two in series, they simply added together, so we got approximately 80. Let's see what happens this time as we dial in for resistance. So we dial in, going to our lowest possible setting until we finally have a reading. In this case, we're going to go all the way again down to 200 ohms. At the 200 ohm setting, we see that we get a total of 19.1 ohms. Now there's something noteworthy there in the parallel circuit. What this means is if you have two resistances that are connected up in parallel to one another, the overall resistance is smaller than your smallest resistance that you have when the two are connected in parallel. So as an opposite effect. So the way to calculate that theoretically is a little more challenging, not so much more, but you'll definitely see that